All right, guys, so sorry I couldn't be with you today. We are competing at our math counts competition, and I'm going to record a quick video for you here on how to do your 7-2 homework. So yesterday we talked about arithmetic sequences, and you have the formula there at the top, a review of what we did yesterday. Today what we're going to be doing is we're going to be using those same formulas, but writing them in a linear function manner. So what you see in the middle there of your notes is you have the f of x equals mx plus b, so that should look very familiar to a slope-intercept form of an equation, where m is going to be that common difference. That'll be the same as your slope. B is going to be your zero term, which is going to be your y-intercept. I'll explain that and show you how to find that in just a second. X is your term number, and y is the value of the term, okay? So if we go ahead and look at example number 1, we want to convert the following arithmetic sequence to its explicit linear form. That's this form right here that I just showed you. And then we're going to create the graph that goes with that. Well, here we have several terms, and you can see that the common difference here to get from one term to the next is to add 3. So there's our common difference. That's also going to be our slope. Now our zero term, to get to your zero term, what you're going to do, this is our first term, right? That's a sub 1. To get to your zero term, you want to actually do the opposite. Instead of adding 3, you would subtract 3. So 1 minus 3 would give us a value of -2, would be the term in front of that term. We call that our zero term, and that's also going to be our y-intercept. So we could write our function now, f of x is equal to, instead of m, we're going to use that common difference of 3 times x plus our y-intercept, or our b term, or our zero term, which is -2. Okay, now to go ahead and graph that, you have a couple of options. You have all of these terms. Our first term, a sub 1 is equal to 1. Our second term is 4. Our third term is 7, and so on and so forth. So we could go out 1 on the x-axis, and we're at 1, so the point 1, 1 is on our graph. The point 2, our second term, goes up to 4. Our third term goes up to 7, so you get the idea here. We can just graph those, and we should get a linear pattern. And you would also notice that our y-intercept down here would be at -2. So you can connect those together and put an arrow on the end there. Number 2, it says convert the following arithmetic sequences to its explicit linear form, same kind of thing. This time our common difference d is going to equal -4, and remember that's the same as m, right? So if we go the opposite direction, instead of subtracting 4, we add 4. That would give us a sub 0 being 22. So then we could write our function, f of x is equal to -4x. Oops, I forgot my equal sign there. -4x, and then our common, that was our common difference, but then our y-intercept would be plus 22. Okay, again, to graph this, we could graph the points. Our first term is 18, our second term is 14, our third term is 10, our fourth term is 6, and you can just graph those as ordered pairs. Okay, so 118, right about there, 214, right about here, 310, 46, so on and so forth. And then connect those and draw your arrow. All right, example 3, use your knowledge of arithmetic sequences to answer these questions, okay? If in a given arithmetic sequence our 63rd term is 914, common difference is 7, what is the value of a1? Well, we can write the formula from yesterday. A sub n equals a sub 1 plus n minus 1 times d. And then let's just substitute in what we know. A sub 63, we're going to call this one 914. We don't know what a sub 1 is. That's what we're trying to find. N in this case would be 63 because it's the 63rd term. Subtract 1 from that, and our common difference is 7. So now you just have a linear equation that you need to solve. So the first thing that you would want to do is take 914 is equal to a sub 1 plus 62 times 7. So if we get our calculator out here, let me grab that really quick. So 62 times 7 gives us 434. Okay, and then we're going to subtract that from the 914. So 914 minus 434 gives us 480. So a sub 1 is 480. And there you have it. Alrighty, in the same sequence, what term would be the first term to exceed the value of 2,000? Well, what we can do is just rewrite that equation, right, that a sub n equation, set that equal to 2,000. So I'm going to go 2,000 equals, now we know a sub 1 is 480, plus, we're looking for what term n minus 1, times d, which was 7. So I would subtract 480 from both sides, first of all, so minus 480 over here. And that would give me, what is that? 1520, right? Is equal to n minus 1 times 7. You could distribute that 7, but I think I'll just divide by it on both sides to get rid of it. So then I have n minus 1 is equal to, let's go ahead and use our calculator. I'm going to make sure I did my math right on that too. So let's do 2,000 minus 480 was 1520. Take that answer and divide it by 7. And we get 217. And then we want to add 1. So this was 217. So then add 1 to both sides. So n equals 218.1. So that's going to tell you that the first one to exceed the 2,000 mark, we're going to round that up. So this will be 218. So you want to round that up. So 219. That would be the first term, a sub 219, to exceed the value of 2,000. Part C, if in a given arithmetic sequence, a sub 42 is negative 312, common difference is negative 3, what's the value of a sub 13? Okay, again, we can use that same formula. So a sub 42 is negative 312. That is equal to a sub 1. We don't know what a sub 1 is, plus n minus 1. That's going to be 42 minus 1 times negative 3. So we're going to have to calculate what the value of a sub 1 is in order to be able to get us to the a sub 13 answer. So 312, negative 312 is equal to a sub 1 plus, this would give us a 41 times negative 3. And 41 times negative 3 is a negative 123. So add 123 to both sides. And let me do my math on here again. So we are going to get negative 312 plus 123 gives us negative 189. So we would have negative 189 for a sub 1. So now we can go ahead and work on calculating what the problem asked us to find, which is the value of term a sub 13 right there. So we're going to go a sub 13 is equal to a sub 1, which we now know is negative 189, plus n minus 1 will be 12, 13 minus 1, common difference of negative 3. So a sub 13 is negative 189 minus 36, and that gives us a value of negative, let's see, 9 and 6 is 15, 12, negative 225, I believe. Let me just check my math just to make sure. I don't want to give you a wrong answer and have you be confused. So negative 189 minus 36, negative 225. Alrighty, so onward and upward. Part D, the first 4 terms of an arithmetic sequence are given. Which term has the value of negative 355? So we're looking to find n, okay? We can look at this and see that our common difference here, it's going down by 7, so it's a negative 7. So we're going to set negative 355 is equal to a sub 1, which is 37, plus n minus 1 times negative 7. So the first thing I would do is subtract 37 from both sides to get rid of that one. And we're going to get a negative 392 is equal to n minus 1 in parentheses times negative 7. Divide both sides by negative 7 to get rid of that one. And we're going to get a positive, let's see, 56 equals n minus 1. So then if you add 1 to both sides, our term number would be 57th. So the 57th term will have the value negative 355. All right, last one. An arithmetic sequence has terms a sub 8 and a sub 19 given. Find the common difference, and then write our explicit function that models the arithmetic sequence. Okay, so a sub 8, we're going to write 59 is equal to a sub 1 we do not know, plus n minus 1 is going to be 7, and we don't know what d is, right? So let's see, a sub 8, and then I'm going to write another equation, so that's my first equation. And let me find the common difference and write an explicit formula. Okay, so let me write the second equation then. A sub 19 is going to be 125, and that's going to equal a sub 1 plus 18 times d. And so now we have a system of equations, two equations, two unknowns. So if you have 59 equals a1 plus 7d, I'm going to rewrite these. a1 plus 7d equals 59. That's our first one. And a1 plus 18d equals 125. We can solve one of those for a1 and do substitution, right? So if I solve this one, I would say a1 is equal to 59 minus 7d. And then I'm going to take that right-hand side and plug it in right there into my second equation. So that equation becomes 59 minus 7d. That's what we substituted for a1, plus 18d is equal to 125. Combine your like terms. So we have a minus 7d and a plus 18d, which gives me a positive 11d. And I'm going to go ahead and subtract 59 from both sides to get rid of that one, and that is equal to, let's see, 125 minus 59. So 125 minus 59 is 66. So that works out nice, so that tells me d equals 6. Okay, so that's the common difference. Our explicit function then would be a sub n equals a sub 1 plus n minus 1 times 6, or we could write our f of x, right? And our a sub 1 we didn't calculate yet, did we? We'd have to substitute that back into our formula. We have a formula here for a sub 1. We could say f of x is equal to 6x, and we just still need that common difference, or we need our zero term. A sub 1, let's go ahead and calculate that. A sub 1 equals 59 minus 7 times 6, which is 42. So that gives us, what, 17 for a sub 1. So if that is our a sub 1, then our common difference is plus 6. We could take away 6, which would be 11. So 6x plus 11 would be one way of writing that. Or we could come up here into this equation, and let's substitute, instead of a sub 1 right there, we could put our 17, right? Because we calculated a sub 1, and that's another way that we could write that formula. So there you have it. Good luck on your homework, and I will see you on Wednesday.